All right, moving on to 6.6, we have trapezoids and kites. These are the last two quadrilaterals that we will learn about. So trapezoids are pretty basic. You've seen this shape before. You have bases and then the legs. And the only property that you need to know about regular trapezoids is that bases are parallel. All right, and then you have isosceles trapezoids. These are the ones that you will encounter more often because there are more properties to talk about. So since it is a trapezoid, we know that our bases are still parallel. And then the properties that are unique to isosceles trapezoids would be that legs are congruent. All right, so we know isosceles triangles, the legs are congruent. These are still legs if these blue sides are our bases, okay? So the legs are congruent. That fits for isosceles trapezoids and triangles. Well then, from isosceles triangles, we know that base angles are congruent, and that is the same for isosceles trapezoids. So, property number 2, base angles are congruent. So since we have two bases here though, what's important to notice is that these two, because they touch both base number 1, if you want to call it that, would be congruent. And then the two at the bottom that touch our bottom base, or we can call this base 2, would be congruent. So if they don't touch the same base, they are not congruent. And actually, that is property number 3, is that then adjacent angles are supplementary. So the ones that are next to each other that do not share a base would be supplementary. And then our last property is that diagonals are congruent. Okay, so if I drew these diagonals in here across this shape, I would know that BD would be congruent to AC. Okay? Those diagonals, the green ones, are the same length. All right, that's all our trapezoid stuff. Let's go on to kites. Kites are really weird, and they have 3 properties that go with them. So the first would be that you have 2 pairs of consecutive, so that means next to each other, congruent sides. Okay? So what that means is these two that are right next to each other are congruent, and then right here and right here that are next to each other are congruent. So with a kite, it is not opposite sides congruent, it's the ones next to each other. Property number 2 is that diagonals are perpendicular. Okay, so that is already marked on our picture. We see that the diagonals that they drew, I'll draw those in green again, met at this right angle. That is similar to a rhombus. I like to think these diamond-shaped figures always have diagonals perpendicular. And then your last property of a kite is that there is one pair of opposite angles congruent. So in all of our shapes so far, we've had opposite angles are congruent, but in this particular case, only one pair of them would be. So for instance, you might have that this one is congruent to this one, which is most likely the case. And if this kite looked a little differently, you could have B and D were actually the ones that were congruent. But you will only have one pair of opposite angles congruent. All right, so now the last thing that I'm going to go over is this isosceles trapezoid mid-segment theorem. So this means the mid-segment of a trapezoid is parallel to the bases and half the sum of both bases. Okay, so a mid-segment is a line that joins two midpoints. And I know these dots right here are midpoints because it split my legs in half, split my leg in half. Okay, and so we see our parallel lines markings here. And you can kind of tell the base 1 is going to be the shortest, base 2 is going to be the longest. So your mid-segment's kind of in the middle. So what we're doing right here is averaging out the lengths of the first base and the second base. So let's try that in example number 1. So I'm actually solving for my mid-segment here. So I'm going to take my bases, 14 and 26, add them together and divide by 2, which gives me 40 over 2, which means x, my mid-segment, is 20. What you will most likely get a problem with mid-segments, it's going to probably look like this, example number 2, where we are going to solve for x. Well, you would do it the exact same way, except what you are finding where your x is going to be different. So I add my bases, which happens to be x and 32 this time. I add my bases, divide by 2, and that should be equal to my mid-segment. That setup is the exact same. You just put your x where the part that you are trying to find is. In this case, it's one of our bases. So to solve first, I'm going to times by 2 to get that 2 out of the denominator. So I'm left with x plus 32 equals 40. And then algebra tells me next to subtract 32 so that I can get x by itself. And x is 8. So that means this base here should be 8. And I should know it should be smaller than 32 and smaller than 20 because it's the shortest one on here. So there are more examples on the back of this as well, which we are going to hit in class. So make sure you have the whole front side filled out. See you in class.